Hi, you're in for a little treat today. Today we're going to be beginning chapter 1, and I have my goggles on because I'm going to work in the lab a little bit. So we're going to begin this chapter 1, talking about atoms. And to understand a little bit about atoms, we need to define what matter is a little more specifically. We said that matter earlier is a thing that occupies space and has mass. And what we're going to focus on is the particle nature of matter, small particles. And the particles that we're going to look at in this beginning chapter were first defined by the Greeks. Greeks called the small fundamental units of what make up all matter as atomos, and we now call those atoms. So that's where we get the word atomos. It's from Democritus, a Greek, probably in the early BC era. So to understand better about matter, we like to classify. We talked a little bit about classification and understanding. There are going to be two ways that we're going to focus on classifying matter. These include their physical state and their chemical composition. Our first stop is going to be learning a little bit about the three fundamental physical states of matter. And we're focusing on the fundamentals. We'll mention one that we don't learn about in Gen Chem, but it is kind of fun to just talk about it a little bit. And let's begin with classifying matter based upon its physical state. Physical states. There are three physical states that we are familiar with, maybe in our Gen Chem or high school class. And we're going to discuss the properties, which are the distinguishing characteristics of these three physical states of matter. And we're going to try to do show you something. We're going to do a little demonstration. So there are three physical states of matter that we focus on. These include solids. And we're going to look at a solid, liquids, and gases. If we can identify particular properties of each of these physical states, it helps us to learn a little bit more about matter that we study in chemistry. Let's begin with the solid. Solid that we might be familiar with, and I have it here, and we can see it. That's some ice cubes, and they started to melt, and that's important. Those ice cubes are solid, and they're solid water. So let's list some things that we know about ice cubes, some of their properties of solids, to help us identify them. So let's begin with solids. Solid. Some of the properties of solids. Well, we call them ice cubes, remember, because they have a fixed shape. They have a fixed shape, fixed volume. When we say fixed, that means it's well defined. Remember, if we know it's a cube and we know the dimensions of it, we know its volume. Typically, these samples only experience vibrational motion. And they're not very compressible. Now, compression means that if we apply a pressure to a sample, there's an appreciable change in volume. So solids non-compressible. So and they can't flow and they can't be poured. Can't flow. Cannot be poured. So if we look at my sample that I have here, notice it's sitting in my hand. It's sitting in my hand. And it's getting warmer. And what happens to that solid as it sits in my hand? We could probably see that. And we probably know that if we're sitting out on a hot day with a nice cold drink with some ice cubes in it, ice cubes start to melt. And that's because what we're adding is thermal energy, and we're encouraging the particles to move more. And this is an example of a physical change. We have solid water that are ice cubes, and we add some heat to it. My hand, for instance, is about 98 degrees. It's almost gone now. It's all liquid. So if we heat it, we add thermal energy, and we encourage particle motion, and we can go from the solid state to the liquid state, and this is known as a physical change. And liquids experience properties that are rather unique in comparison to solids, but we're going to show how they have similar yet unique to gases also. So what do we know about liquids? Well, particles. Remember we said solids are fixed? Well, when we have a liquid, the particles, they start to experience disorder. They start to move around. So they're disordered. Okay, what else do we know about them? Well, that liquid is about 10. If we look at that, that's a beaker. A beaker is a good way to measure a small amount of a sample of liquid. It's not the most accurate, but that sample, it's taking on the portion of the container based upon the volume in which it's confined. So it doesn't take on the whole shape of the container. It only takes on a small portion. So, like solids, liquids have a fixed volume. So they do share some properties, and they assume the shape of the container in which they're confined. Notice that that's the liquid. Well, what I can do, I'm going to get something kind of cool here. Hold on. We can do a little change here. And this is what I mean by taking on the shape of the container. This is a volumetric flask. I'm going to pour that liquid in there, and notice the shape of the liquid is now different. It has a round shape to it. So the liquid takes on the shape of its container. Pour it back in there. That's what's important about liquids. That's one of their properties. So they have random motion. They're more randomized. Like solids, liquids, we can't compress a liquid. If we put pressure on it, there's not going to be a real big change in its volume. So like a solid, liquids are non-compressible. Unlike solids, liquids can flow if we have a sink and open up the faucet. And as I just showed, liquids can pour. I poured this into another container. Now, one of the reasons why liquids can pour is that they experience intermolecular forces and the particles slide over one another. So let's think about what happens if we add heat to our liquid. And now this is where we're going to take our sample, and I'm going to put this on a hot plate for a few minutes over here in the hood. I'm going to heat it up. So if we heat our liquid sample up, add some heat, liquids are going to boil, and they're going to go into the gas phase. Gases are very dissoluble. Gases assume the volume of the container in which they're confined. Gases also experience very random motion. We'll say extremely random motion. Gases are compressible. If we apply pressure to a gas, there's going to be a really big change in their volume. Gases flow, but we can't pour them. But cannot be poured. Okay. Now, notice that these changes that we involve from one physical state to another often involve some kind of energy, and that's heat, thermal energy. We can go from a solid water that's ice cube into its liquid phase by adding heat, and that's because now we're encouraging more particle motion, and we allow eventually the liquids to escape into the gas phase. Now, these processes of changing from one physical state to another, completely reversible. If we cool a gas and go in the opposite direction, we would see that the gas would then condense into its liquid form. This is what we see in the morning when we get up and the grass is wet, because the night before it got cold and it was muggy. The cold air condensed onto the leaves on the grass, and we would get a liquid. Likewise, if we cooled the liquid continuously, we would freeze it and we would convert it into its solid state. Let's see if the sample that I have. Let's look at another property of gases. So there's the sample that I have. And if you look carefully at it, you can probably see, hopefully, the vapor coming off that liquid. Now, notice the vapor that comes off the liquid. It's allowed to escape into the room, and it says to expand indefinitely. And notice also on the sides of the container, as it gets cool, that vapor is now around the inside, and if it's cool on the outside than it was underneath, it starts to condense onto the side of the container. So those are important properties of physical states of matter. Let's review them one more time. Solids have a fixed shape, they have a fixed volume, and they experience only vibrational motion. They're non-compressible, they can't flow, and we can't pour them. Liquids are slightly more disordered. They have a fixed volume based upon the container which they're confined. They experience random motion, They're non-compressible, and liquids can flow, and we can pour them. Now gases are very disordered. They assume the volume in the container they're confined. Well, another way to think about it, since we can compress a gas, we can compress it into a container. We could take a room full of gas, propane, and compress it into a little green tank. So the particles of gases experience extreme random motion, and as we said, they are compressible. Gases flow, we can measure their rate, but we can't pour a gas. So these are how we distinguish between different physical states of matter. And that's an important way as a chemist to learn more about a sample of matter. Next we're going to go into our next video will involve classifying matter based upon its chemical composition.